So, you work in a company that prints and publishes books. You are responsible for designing the page numbering mechanism in the printer. You know how many digits a printer can print with the leftover ink. Now you want to write a function to determine what the last page of the book is that you can number given the current page and number of digits left. Okay, so I don't know if it's going to mention in the description, but I think something that's really important to note is that we have not yet numbered the current page. Okay, so it's the current page that we want to put a number on, not the current page that we've already numbered. Okay. A page is considered numbered if it has the full number printed on it. So for example, if we're trying to number, if we're working with page 102, but we only have ink for 2 digits, then this page will not be considered numbered. So the 1 and the 0, not enough. Okay, it's guaranteed that you can number the current page and that you can't number the last one in the book. Okay. I was a little hung up on this part for a second there, but I see why they mentioned that. So we're just going to assume for the purposes of this problem that the book is infinitely long, right? We're not going to get to the end of the book. So just one fewer thing to worry about. Okay. So they give us a couple examples. And the first one, current is 1, and the number of digits is 5. So this one's fairly straightforward in the sense that they're just 1-digit pages anyway. So we'll do 1, we'll do 2, we'll do 3, we'll do 4, and we'll do 5. Okay, so number of digits refers to the number of digits that you can print with the amount of ink that you have remaining in total. Okay, so basically, in this case, we were able to do 5 digits. Well, each of these are just 1-digit numbers, so that's fine. So we get 1, 2, 3, 4, and 5. Okay, and then for the next one, current is 21. We have 5 digits available. We could do the 21. We could do the next one, the 22. But for 23, we don't have enough for the 3, so forget about it. Okay, current is 8. Number of digits is 4. This is actually a really interesting one because basically 8, fine. 9, no problem. But as soon as we get to 10, now that's going to take 2 digits, so we're not going to have enough for any more. So I'm glad they included this one to sort of complement the one above here, the 1 and the 5. Actually, this is a really good set of examples here, I have to say. This is really descriptive because they're showing us like a straightforward example. And they're showing us an example with multiple digits. They're showing us an example of what happens to the leftovers, if there are any, which is basically nothing. They get evaporated. And they show us what happens when we're like going across a boundary, so to speak. So as we pass the threshold from single-digit numbers into double-digit numbers. So good set of examples, very, very descriptive. I think, you know that saying, how they say like a picture's worth 1,000 words? Well, hey, an example's got to be worth at least 1,000,000. Anyway, let's keep going with this. So let's actually try to come up with an algorithm for this. I want to start with something fairly straightforward, like fairly literal in terms of how we're interpreting this. So basically the way I want to do it is we've got our current number. Our current number is going to be, let's see, what do we actually want to return here? The last number that we're able to print? Okay, so basically I'll just say let last num, okay? Just, yeah, last num. And it's not going to be anything right now, but we'll give it a value in just a sec. It's the thing that we're going to be returning in the end. Okay, so I guess, let's see. We'll want to put this into some kind of loop, but before we do, let's just think about what's going to be inside that loop. What's going to happen in that loop? So we'll say something like, here, actually, you know what? I'll put it in a loop, but it's just going to be an infinite one for now. So we'll just while true, and then we'll refine that afterwards. Okay, so while true, what's going to happen? Well, basically, if, I guess we'll modify these things sort of in place, right? So if number of digits is less than, and we kind of want like some way of finding the number of digits in a number. So maybe we'll do something like digits of current or something like that. Yeah. If it's less than the number of digits in current, then we're going to say break. We're done. Okay. Yeah. Yeah, okay. And then otherwise, we'll say last num is going to be current. So we'll say, yeah, we were able to print that one. No problem. Then we'll say current plus plus. And then we'll say, actually, even before we do current plus plus, we'll say number of digits minus equals digits in current. Okay? Yeah. Great. So let's make a function for that, I guess. We don't really need to. Maybe that's overkill, but who cares? So we'll call it digits, and it's going to take in a number. Ultimately, I would have wanted to call this function number of digits, or maybe I'll call it digit count. Yeah, digit count. That's better. All right, let's copy that into the places where we're using it. Digit count. Nice. And so how's this going to work? Well, there are a couple ways we could do it. You know, one way we could do it would be to say like return num dot to string dot length. That's probably the most straightforward way of doing it, I would say. So let's see. I don't know if we need anything else here. Is this going to do what we want it to do? Yeah. Okay, cool. Well, isn't that cool? I always love it when that happens, when you're just kind of like, surprise, we're at the end, we already have it. Yeah, so basically Rainbow asks about like putting this after the return. Like, doesn't that seem a little fishy? Like, notice how the digit counts are green over here. And yeah, it is kind of saying like, well, hey, we don't know what digit count is. We haven't seen that yet because it's not like it's up here or anything like that. I mean, we could put it up here and that's going to make these things blue. But yeah, that is something that happens automatically as it's executed. And yeah, hoisting is basically what they call it, as you mentioned. We could even just like pop this out here if we wanted to. Digit count doesn't need to be part of the inner function here. I don't know if there's like an advantage or a disadvantage of taking it out of the scope of this function. I guess, well, okay, in terms of advantages, if this was like a bigger project, like a web app or something like that, and we needed to do digit count in other like at other times, like for other functions and stuff like that, then yeah, we would want to make it accessible to everyone who needs it. It's kind of like, okay, a good example of one that I use a lot in this kind of style is random color. Like I'll usually make like a random color function and just use that in any part of the app where I need a random color, that sort of thing. Okay, so we've got this. I actually am just gonna stuff it back into this function, and the reason I'm going to do that is just because we'll look at a few different ways of doing this, and I sort of want them to be kind of self-contained. Okay, so this is a way of doing it, right? I'm going to modify this slightly. I'll just say const digits is digit count at current, just so we're not actually calling this twice, and then we'll just put in digits over there. It's not like it's going to change, right? Like the digits that we have up top is the same as the digits that we're going to have down here, right? It's not going to make much of a difference. So yeah, that still works. Good. Okay, excellent. All right, so we've got number of digits minus equals digits because we're like spending them, you know, we're actually printing that page number. We've got last num is current because we actually are able to print that page number. And then we've got current plus plus because we want to move on to the next page, right? See if that one's going to be possible. So I'm wondering, maybe there's a better way we could do this. Maybe we can make it like a for loop and put the current plus plus at the end of it. What do we need to like initialize at the beginning? Oh, okay. Hey guys, check it out. Let's do something fun and weird for this. Okay, so let's make this a for loop and we'll do something fun and weird with it. So what do we know about this for loop? Well, we want it to go, well, okay, first of all, we want it to do this at the end of every iteration, right? And I think if I were to run this now, it should actually work, I think. Yeah, it's kind of weird because there's nothing here and there's nothing here, so it seems kind of strange for a for loop, but yeah, it does work like this. I mean, basically it's the same as just putting true here, right? It's just gonna keep going, keep going. Under what circumstance do we want it to actually break? Well, it's if number of digits is less than digits. Well, what's digits? It's digit count at current, right? So could we just put that in up here? Like if number of digits is less than this, actually we want it to be greater than or equal to that, right? Under those circumstances, then we're gonna make the next iteration happen, right? So does that mean we can get rid of this over here? Because that'd be kind of nice. Yeah, okay, so that's cool. And then we've got last num is current. You know what? Here, first of all, this down here, like, ooh, no. I was gonna say, like, could we put this up at the top over here? But no, this part over here before the first semicolon only gets executed right at the very beginning of the loop. So we'll put something else in there in just a sec. But this is the main stuff that we want to have inside the loop. right? Yeah. Okay, cool. Now I'm going to do something, I'm going to do something a little sneaky here. I'm going to change this to just a single character. Why am I doing that? Well, I'll show you. So basically, here's another way we could say this. Const d is assigned the value of something that takes a number to num.toString.length. Yeah. So would this still work if it was written like that? No, it's saying d is not defined. So apparently this part is not getting hoisted in the same way as that other stuff, like if it was a function. So I guess function hoisting and variable hoisting are a bit different, but check it out. I'm gonna stuff it right in here. This is something we're using in this loop, and really only in this loop, so we don't really need access to it outside of the loop. I could define it right at the very beginning of the loop if we really wanted to. And let me just sort of, just in terms, like in the interest of keeping the size a little smaller, I'm just reducing these to single characters. But that's generally not a great practice, so I wouldn't necessarily recommend that. Okay, cool. So, pardon me. Oh, hold on a sec. All right, sorry about that. Okay, so continuing with this then. I mean, this is passing the sample test, the visible test, right? Is it going to pass the elements? Let's find out. So let's try that. Oh, you know it does. And look at that, we're getting closer and closer to that Soldier 1 badge. Whew, can't wait. Oh, hey, that's nice of you to say, but no, not right now. Okay, so what do we want to do with this? Well, first of all, this is kind of wacky. Yeah, Rainbow's saying, huh? A constant for this over here? Well, yeah, we're saying that the function itself is a constant. What it produces, like the outputs of that function, are not necessarily be constant. But it's not like we're going to reassign the variable d to be like some other function later on. So it is a constant. And furthermore, like, my understanding anyway is anytime you're to do like, you know, function thing, which does this or whatever, this is the same as saying like const thing is assigned the value of function that does whatever, right? Like these two things, these are the same, you know, two different ways of saying the same thing, as far as I understand, because I don't think you'd be able to reassign thing here, you know, like I don't think this is now a function that could like take on some other or like the name thing, I don't think could take on like a different function, just like this over here. So I'm pretty sure that this is more like a const than it is like a let or whatever else. Anyway, does that address your issue there, Rainbow? Hopefully. Okay, so this was kind of a weird way of doing it, right? We were able to agree on that, so it worked, but it was kind of weird. So I'm going to X that. I'm going to do like a billion undos to the last kind of stable thing that we had. Yeah, like even before it was a for loop. I'm just going to keep it in the while loop for now. So let's try running that. And okay, that's going. Okay, so that sort of answers it, but not quite. Well, help me understand, Rainbow. What's the issue? And I'll just get started on making a new one of these in the meantime. I'll cut that and do a reset. Yeah, because it seemed like the const was kind of strange. Like, is it the fact that it's in here, or is it the fact that it's like attached to a function, or like what seems to be the main issue with it? On every iteration. Well, keep in mind though, since this is a for loop, this part will not run on every iteration. This is basically just like the initial conditions, right? So basically we're just saying for, and normally this is where you'd say like, actually, hold on, let me just do another little visual example down here. So like this is a very typical way of seeing a for loop, right? We've got let I be assigned the value of 0, I is less than some length. We don't actually have that as a thing, but anyway, and then I plus plus. So yeah, exactly. It executes once. So basically, like this part is only going to execute once. This is going to happen at the end of every iteration, and this is going to happen before every iteration to check if it actually should do that iteration, right? So the fact that this only executes once is why we're using a constant over here. The thing is, we wouldn't be able to use a constant on this thing because we actually do want to change the value of I, whereas over here, we don't want to change the value of D. We're going to use that on every iteration, and that's fine, but we're not going to change what D actually is. Okay, so that's better. That's making more sense then? Okay, cool. So let's keep moving on from here. So actually, you know, while we're here, let's just paste this in because I want to do something really, really similar. Or this one, maybe. I don't know. Whichever one you prefer. I just want to actually change this. This is the only part I want to change for now. So instead of converting to a string, because like, that's a little sloppy, right? We don't want to have to convert to a string if we don't have to. Instead, we'll just get the number of digits in a different way. So one way we could do it would be something like this. Let digits be assigned the value of 0. And we'll say while num is assigned the value of Math.floor of num divided by 10. Okay, so we're basically just shaving off a digit from the end when we do that. If you're not convinced that that's the case, take a look at this number over here, right? 102. If we were to divide that by 10, that would give us 10.2, right? The sneaky little decimal place in there. And if we were to round that down, we get 10. So we're basically just chopping off the 2 in that case. And then again, if we do this, you know, divide it by 10, we get 1.0. Round that down, it's just 1. Well, it's just 1 either way. Anyway, the point is, so we got this, we're taking off a digit, and because we're taking off a digit, let's add it to our count. And at the end here, we just want to return our number of digits, which we're calling digits. So let's try running that, and yeah, that works too. So that's another way we could do it. Yeah, I guess we'll, you know, count these all as like different ones. There's maybe going to be a lot of these today. So, okay, that's number 3. Let's move it down. And this will be, yeah, eventually number 4, but for now, it'll be something different. Let's just say return 0 for now. I just want to make sure this is the actual function that's running and not some other one downstairs that's like still active for whatever reason. Yeah, okay, cool. Good. That's what we want. So, all right. There's another way of doing a digit count that's a little more mathematical. So instead of using a conversion to string, instead of using a loop, we're going to use a mathematical operation that's going to help us out here. So specifically, let's go over here for a sec. So what operation am I talking about if we want to know like the number of digits? Well, let's think about that. So let's write out some numbers. So we've got, whoa, hey. We've got 6, we've got 13, we've got 259, 4,196. I think that's a power of 2. And that's enough numbers for now. So basically, if we want to know how many digits there are, my claim is that we can use logarithms. Okay, so how does a logarithm work? Let's just review that for a sec. I know we've talked about it before, but let's say we've got a situation where we've got like b to the power of x is equal to p, for example, right? So base to the power of exponent is equal to some power. My claim is that equivalently, that could be written in logarithmic form as, I'll just write it below. So let's say log, whoa, okay, no, that's an unacceptable LO. There we go. Log base b of p is equal to x. So notice the p in parentheses there. This is a math function, so very similar to, come on, man. All right, very similar to a programming function. It takes an input. So this is our exponential form, and then our logarithmic form down below is basically where we're using log as kind of like a function, right? So, well, not even kind of, it's totally a function. So log is a function, takes in an input. What does it give you? Well, it gives you the exponent that would make it true. That's the idea, okay? So if we had something like this, let's say, all right, what's a power that we know to be true? So we'll say something like 2 to the power of 3 is going to be equal to 8. Okay, so equivalently, if we wanted to put this in log form, it'd be log base 2 of 8 is equal to 3. Okay, so when you see a logarithm like this, you know, specifically when you see this thing right here, okay, log base 2 of 8. If you're wondering, what is that? What is the answer of that? You know, what is that? Then basically, this is asking you the following question. It is saying, 2 to the power of what equals 8? Well, 2 to the power 3 equals 8. We see that right up here. So the answer is 3. Okay, what we're looking for when we do a logarithm is a missing exponent. 2 to the power of what equals 8, or more generally, b to the power of what equals p. Okay, so, and yeah, ATD, I agree with you, man. Very, very powerful tools. Would we call it calculus or algebra? The thing is, it could be used in either one, right? But typically, like where you see it in high school math is pre-calculus, or in Ontario, we call it advanced functions. It's in grade 12, your final year of high school. Although it doesn't have to be that way. I mean, logarithms are fundamentally something you could understand when you're 6 years old. It just happens to be the curriculum that way. Anyway, the point is, if we're looking at these kinds of things, we want to know how many digits they have, right? But keep in mind, we're talking about a decimal system, right? So we deal in powers of 10. So we're going to use log 10 on these things, and we're going to see what we get. So I'll put in the log 10s, I guess, over here. So actually, hold on a sec. These are going to be weird numbers, right? So if anyone in the chat wants to help me out with some values here, that would be really helpful. So we want to do log base 10 of 6. We want to do log base 10 of 13. We want to do log base 10 of 259. And we want to do log base 10 of 4,196. And we want to get those values. If no one in the chat is able to get those values to me in time, I'll just go over to desmos.com/calculator. And it looks like that's what we're going to do. So I'll go to desmos.com/calculator, best calculator app. Log base 10 of 6. Okay, so we got 0.778. Let's get that number in. Let me just move this tab over so they're a little closer. Okay, so 0.778. Okay, now we want to do log base 10 of 13, which is 1.114 approximately. 1.114. Yeah, okay. And then let's do, I forget what the next number was, 259, 2.413. Okay, we're maybe noticing a bit of a pattern for this, but yeah, who knows. And then the last one was 4,196, which is 3.622. You remember how I mentioned earlier that 4,196, I believe, is a power of 2? Well, we could check that. We could change the base here to 2. Whoops, not like that. Change the base to 2, and whoops, I guess I was wrong. I was thinking of this number. Okay, cool. So let's go back to this. And, oh, thanks, ATD. Thanks, Rainbow. Both of you guys. Good job. Okay, so we've got our logs here. But what was even the point of this? Well, the point of this is the following. I think with this in mind, with these numbers here, we can make a prediction about what log base 10 of the following number would be. So I'm just going to choose, I don't know, some random number, just going to pull out of thin air, and we'll put it in here. And we want to take a guess as to what the first digit is going to be. Okay, so does anyone want to take a guess as to what the first digit is going to be when we take our logarithm of this thing? Any guesses? Based on what we have over here, based on the patterns that we're maybe noticing, just touching this number up, just totally randomly. Yeah, it's probably going to be 2 point something. How do we know that? Or at least let's verify that first, and then, yeah, wait. Log base 2. That was almost a very embarrassing moment. Okay, here we go. 2.823. So 2.823, hey, we were right. It was a 2. How did we know that? How did we know that? Well, it's because when we're talking about logarithms, we're basically talking about powers of 10, right? So when we're talking about powers of 10, log base 10 of 10 would be 1. Log base 10 of 100 would be 2. Log base 10 of 1,000 would be 3. Log base 10 of 10,000 would be 4, etc. So basically, if you're between 100 and 1,000, like this one over here, that means you're going to be between, your log base 10 value is going to be between 2 and 3. Okay, so it's going to be 2 point something. If you're, let's say it was, well, okay, we'll talk about this one. This is between 1,000 and 10,000. So log base 10 of 1,000 is 3, log base 10 of 10,000 is 4. So log base 10 of 4,196 should be between 3 and 4, and it is, okay? Now, if we were to look at actually like log base 10 of exactly 1,000, then that would be 3. But really, that's, if you think about it, 1 less. than the number of digits, right? And if we were to take the floor of these, it would always be one less than the number of digits. So that's what we're going to do. We're going to take the floor of log 10, and then we're going to add 1 to it. Or maybe even we'll take log 10 and then add 1 to it and then take the floor of it. It doesn't really matter, but we're basically going to do something like that. Okay, so we're going to do return math.floor of math.log10. This is a nice thing. Okay, keep in mind, back in the day, we weren't able to use this, right? Back in the day, if we wanted to do math.log10, we'd have to do math.log of num over math.log of 10, which is known as the change of base formula. Very useful tool, but if we can avoid it, probably nicer to just use log 10. Okay, cool. Yeah. So Rainbow is basically asking if we can take the floor and then add 1, but he wants to do it in kind of a bitwise way, so we will oblige. So we're going to say 0 and then bitwise or this thing, and that should typecast it into an integer value because bitwise numbers, I don't think they support floating points. So, okay. Well, that's nice, right? I think that's the nicest one yet, maybe. Like, if we take a look at this, num.toString.length, it's close in terms of character count, but I think I like this one. Well, okay, it's not that I think I like it. I definitely like it more. This is a better way to do it, is what I would say. It's more mathematical. It's, yeah. Well, okay, sorry. This one was also very mathematical, but it required a loop. This one does not. So this is just one step. We get right to the answer. We've got what we're looking for, and everyone's very happy. Yeah, everyone's very happy. Okay, cool. So this is going to be part 4 in our series of solutions here. We're going to clear that because guess what, dudes? We're doing it again. Okay, so check it out. Let me paste that in. We've got all of our previous solutions down here. I maybe shouldn't have hyped this up so much because now I'm now realizing I don't even know if, oh my God, Rainbow, you're right. Hold on. Before, yeah, stop the presses. Our work here is not done. Wow, you're absolutely right. So true bitwise would be to do it this way. So not even the +1, right? Like just take this and do negative, not this. Is that gonna work? Did I do that right? Yes. Okay, cool. So, okay. If you want the backstory behind this one, like why this works the way it does, I would definitely recommend checking out my YouTube videos from the corner of zeros and ones. We talk a lot about bitwise operators there. There is also, Rainbow gave me a link today, this site over here, LeetCode. So this has a lot of tricks on how to use bit manipulation. I don't know if it has this particular one on it, but it's got lots and lots of stuff here, lots of content. I was actually really surprised by this. Anyway, where were we? We were over here. Okay, so basically, yeah, like I was saying, if you want to get the background on why this works, take a look at my bitwise videos because it did take a bit of time to really get into, like, get in depth and explain this fully. But essentially what happens is if we do the not, the bitwise not, it's doing a couple things. So it's typecasting it into a whole number, and then it's basically doing negative that number minus 1. So then if we take the negative of that, then it's going to be positive this number plus 1, which is what we want, right? And it's also Math.floor. So cool. I hope that passes the Rainbow Sprinkles test of approval. I know you're sort of the bitwise guy in the chat here. So thanks for pointing that one out. That is a true bitwise solution now, I'd say. Okay, so we'll clear that. We'll reset this. We'll bring our other stuff down here. And yeah, okay, cool. So we want to do this in one more way, but I have to say, I don't actually know if this is going to work. So I'm taking a bit of a gamble for this next one. I just have this sneaking suspicion. I have a feeling that it's possible to do this one maybe without loops. I think it's possible to do it without loops. Yeah, I could be totally wrong about that, but I kind of think it's possible to do it without loops. So, yeah, we're going to give it a try. I don't think we're going to get it to a point today where we'll be able to do it without loops, but I think we'll be able to get it to a point where we're going to have a very, very small loop. Yeah, that we will end up using, but only like, it would iterate like 1 or 2 times max. sort of thing. So that's the plan anyway. So we're going to say let size be assigned the value of, I guess we might as well do what we just did. So we'll do math.log10 of current. Okay, so we're starting with current over here. Is that going to work? Let's see. Let's just return size, make sure I didn't make any mistakes so far. Okay, we're off to a great start. Our one line of code is working, and it's giving us basically the number of digits in our number. Well, we can sort of make a prediction about how far we're going to be able to get with this, right? I mean, if you think about it, like we could say how many more numbers, how many numbers away from the original one are we going to be able to proceed from the beginning, knowing that we have this number of digits left and that each number takes this many digits. Well, basically, it's going to be something like this, right? We'll take the floor of number of digits divided by size. That should be sort of how many numbers we're going to be able to iterate upwards. So in this case, we're saying 2. In this case over here, we're saying 4. In this case, we're saying 5. Technically, I think I should be subtracting 1 off of this because we're not going to make it that many numbers. Yeah, okay, so starting at 1, we'll be able to make it 4 numbers ahead of that one, right? So basically 1 plus 4, it's 5. Okay, in this case, we're only able to make it 1 more number. So we start at 21, we add 1, we get 22. So maybe if we just take our current number and then add this thing to it, then will this work? Let's try it. Well, check it out. It's working for half of them. Half of the sample tests anyway. Actually, let's try submitting. Let's see how many of the hiddens. Not bad, to be honest. I mean, look at this. 7 out of 11. That's pretty not bad. Okay, so well, I guess let's investigate what's going on in the cases where it's not working. So this is a case where basically it ends up sort of iterating to the next level. So the digit size increases. That's basically what I'm trying to say. Now this is where things get complicated, and I haven't even really thought about how we're going to proceed from here, but I'm sort of thinking, you remember how I was saying before that like maybe there's going to be one loop that we'll use, but it won't be very major. So the loop I was thinking is that we might do something like, for example, run a loop that only iterates every time there's a change in the number of digits, okay? Now, this isn't going to happen very many times because if we take a look at our numbers here, I mean, both current and number of digits could only be as great as 1,000. So I think that means like 2, maybe 3 times we're going to have to iterate this loop we're about to do. So what is this loop going to do? Well, okay. Maybe we should like give a variable to this. So let, I was about to call it current. Let stopping point, I don't know. Let's say end for now. Let end be this. I don't know. Oh, hold on. Let's not do it that way. Let's add it to this. So let's say additional. Yeah. Okay. Okay. Yeah. And Rainbow is saying, yeah, why don't we just put in 1 or 2 if statements instead of a loop? We might find that it might be less efficient to do it that way. We're going to see, because it might be that the if is going to depend on some other things. So yeah, let's find out. I don't want to be too cryptic here, so let's just actually do it. Okay, so we've got our size over here. And I guess what we want to do is we sort of want to know like what's the next digit up and how far is it from that. So like, for example, if I were to do just return 10 to the power of size, what am I going to get for that? So 10. In this case, if we start at 1, then 10 is kind of like the next number where we're going to have a digit increase. In this case, yeah, 100 would be the next number where there's going to be a digit increase. So really what I want to do is I want to say let remaining digits or remaining numbers. Yeah, remaining. I'll just call it remaining. Let remaining be this minus the current. Okay, so let's see if that works. Okay, it didn't. So that's because I didn't return anything. So return remaining. That's what I wanted. Okay, so there we go. Yeah, at this point, we would have to go through 9 numbers in order for this to be actually iterated to the point where it's, problematic, right? In this case, we'd have to go through 79 numbers to actually have a problem here. Now, in this case, we'd only have to go through 2. And then instantly it becomes a problem. So actually, hold on. I'm returning remaining right now. I want to just do a console log of remaining and additional. So console.log remaining additional. Let's try this. Okay, so we got 9 and 4. That was fine. We only need to go up 4 numbers. We are able to go up 9 of them before there's actually going to be a problem. Or technically 8 of them, right? Because at the 9th one, that's where it becomes an issue. In this case, we could go up 78 of them, so 1 is definitely fine. Now, in this case, we're safely able to go up 2, and we need to go up 3. So that's why this one is becoming a problem for us. So I guess what we want to do is something like this. So we'll say if additional is greater than remaining, or should it be greater than or equal to? Let's figure this out. So in this case, would it have been a problem if this was a 3? I think it would be, right? Yeah, I think it would be a problem because basically if there are only 3 of them, 3 digits, then we wouldn't be able to do the 10, right? So we'd have to stop there at 9. Yeah. So if it's greater than or equal to, I think we're going to have to do something to this. Now, what is it that we're going to do? Basically, I guess what we need to do is for the ones that we're able to... Okay, hold on a sec. Let me think about this. So we kind of want to like shave off from... Hold on a minute. Okay, if this is going to happen, this means that we're getting to a point where our number of digits are like changing, right? So that means we're going to be able to get, hold on, let me use a concrete example for this. Let's say we're talking about this one, okay? So we're starting with 1-digit numbers, and we're saying at this point we are going to get to a point where there are 2-digit numbers. So what I want to do is say, okay, well, this means you will get to a point where there are 2-digit numbers. When you get to that point, let's take off all the 1-digit numbers. So we'll say number of digits minus equals like remaining times size, I guess. Or no, remaining. Remaining times size, because remaining is how many numbers there are. Size is because remaining and additional are both measured in terms of how many numbers there are. Size is the actual digits of that. So I'll say minus equals size times remaining. Okay, and now I just want to do a little console log of number of digits. I regret using num as a variable. It's very frustrating right now. Okay, so my console log is not happening there. That makes sense. It is happening here. So it's saying at this point, number of digits minus equals. So yeah, it should have 2 digits left. So it looks like this part is being done correctly. So now we need to reassign size. So we're going to say size is going to be, hold on. So we'll say current is going to be 10 to the power size, right? Because that was sort of the next plateau. So if we did make it there, then yeah, we did make it there, right? So 10 to the power of size. And now we want to say that size is going to be, let's just do a plus plus. It's easier to do it that way, right? Okay, so then additional is going to be reassigned, right? So additional is going to be Math.floor of number of digits divided by size. Both number of digits and size have changed. And now over here, we want to do return current plus, what was it? Additional minus 1? I don't remember if that was it. Let's see. Are we passing any of them? No. Oh, the minus 1's already there. Okay, my mistake. Sorry. Ooh, hey. Look at that. We are doing it with one if. But I doubt that's going to pass all the hidden tests. Let's find out. Oh. Well, okay. Hey, guys, check it out. Guys, look. We just did it loopless. We did it. We did it without a loop. Can you believe it? Let me tell you, okay? I want to give you a bit of a backstory on this, about what just happened here. So, part of the reason I did not stream yesterday is because I did not feel sufficiently prepared to teach this problem. If you want to teach something, you have to know it 3 times as well as just doing it, okay? So I did not feel confident in my ability to teach this one yesterday because I hadn't spent enough time with it. I mean, I was aware of these kinds of solutions, but I just had this sneaking suspicion that there was another level to it, that there was something like this that was just waiting to be discovered. I spent a lot of time earlier today, just going through other solutions, looking at the top rated solutions. I did not find a single one that did this without a loop. So I think we can be proud of this. We did it, guys. We solved this thing without a single loop. Now we could use something like a while over here. I think that would work in case we had something like, oh, maybe not. Why doesn't it work for this? Whoa, okay, that's something. All right, forget I even said that while thing. It was a silly suggestion. Anyway, I was expecting we were gonna have to use like a while or something like that, just because like I figured this thing where we're like crossing over into the next set of digits, that's probably something that could happen more than once. I don't know, it's conceivable, right? So I figured it could happen, but I guess it didn't happen in any of these tests. So we are kind of exploiting weak test coverage in this case. But, you know, if there were more extensive tests in here, then we can modify our algorithm. We sort of have the skeleton outline here anyway. Okay, cool. So, anyone have any questions on that? I'm excited about this. I think this is actually super cool. This could probably be a bit better. Like we could, I suspect, probably clean it up a little bit, but I don't know. I'm satisfied with it. I think it's good. I'm actually really happy with it. So nice job, everyone. Let me know if you have any questions, comments, concerns. And as for now, let's get out of here. Yeah. Nice job. You did it.